All right, good morning. Happy Friday. Okay, let's see here. I think I have the problem figured out. I do think it's my internet, and I have a technician coming out on Monday. So as far as this glitching and me freezing and lagging, I'm hoping I can get it resolved as soon as possible. So just hold on and keep letting me know if there's problems, but hopefully the issue will be resolved on Monday. Today, I want to finish the lesson on 12.2. And then what we're going to do is work most of the time in our Math Wizard teams, but the practice AB is, you're going to have some problems that I need to go over because they weren't in the lesson, but you're expected to know how to do them. So, but before we get started, anybody want to ask me any questions about, I think 12.1 is due tonight, so you should be done with it. Just turn it in. Any questions about arithmetic sequence or geometric sequence at this point? Any questions? No? Okay. All right, so let me finish this lesson. I'm calling it lesson 12.2 part 2. And in part 1, we looked at explicit and recursive rules for geometric sequence. Remember, a sequence is geometric if it has a common ratio. So it's arithmetic if it has a common difference. It's geometric if it has a common ratio, and ratio means fraction. So we also looked at graphing, geometric sequences, and with the if something is written in the explicit rule, we can just use a calculator and look at the table. If it's a recursive rule, you have to do it by hand unless you have a program on your calculator to do it for you. So I just want to, we want to look at a modeling problem now, and I'll be done with the lesson. And then what I want to do is I want to work a couple problems off of practice AB that you may not be able to do. All right. So can you guys look in your books on page 608? Actually, it's 603. I lied. 603. This is actually a tennis tournament problem. So if you read with me, please. It says the Wimbledon Ladies Singles Championship begins with 128 players. Each match, 2 players play, but only one moves to the next round. The players compete until there's one winner. How many rounds will the winner have to play? So when it's all said and done, how many rounds did the winner have to play? All right, so what they want you to do is they want you to write both an explicit rule and a recursive rule. And then they want us to use one of the rules, and we use the explicit rule to solve the problem. Okay, all right, here we go. Now, the first thing I'm going to do is I'm going to kind of just analyze the problem of what we read. So what did we read? We read that the first round requires 64 matches, right? Now, it did not explicitly say that. But if there's 128 players, the first round is going to require 64 matches, and that is going to be our A sub 1. Okay, the next thing we can figure out is that the next round of matches requires a half as many matches. And that's going to be our common ratio. All right, so from that, we can write the explicit rule. And once again, you have two rules. One starts with the position 0 and one starts with the position 1. So we're going to use the one with position 1, f of n is equal to a times r to the n minus 1, where n is greater than or equal to 1. And we can write our rule. F of n is equal to, the starting term would be 64. Our common ratio would be 1/2 to the n minus 1. Okay, now the recursive rule am I lagging or cutting out or anything right now? Okay, good. It's weird because it's saying I have high-speed internet, but then it cuts out. I don't know what's going on. All right. So the recursive rule would be f of n is equal to r times f of n minus 1. And since this started at 1, the recursive rule would start at 2. And so our rule would be f of n is equal to the common ratio times f of n minus 1 for n greater than or equal to 2. Okay, so how do we solve this? Well, let's think about this for a second. Don't we want to get down to the final round, which would be one match? So let me write down the recursive rule. So the recursive rule is f of n is equal to 64 times 1/2 to the n minus 1. So we don't want n to be 1. The final round will have one match. So what we want to do is we want to take out f of n and put 1 in its place. So we're not putting 1 in for n, the position. We want to go down to the final match. So what you have here is you have 1 is equal to 64 times 1/2 to the n minus 1. And what you have here is an exponential equation. Now, we haven't solved these yet. And so there's a rule that they threw this in here, and there's a rule you haven't even learned yet that I have to give you in order to solve this. So let me show you the rule. The rule says if the bases are equal, so if you have b to the m equals b to the n, the rule says that you can cancel out the bases and equate the exponents. So let me say this again. I know this is a weird rule. It says if you can get the bases to be the same, you can cancel out the bases and equate the exponents. So check this out. You know how we usually isolate the variable, whether it be a quadratic, a cubic, absolute, anything. We're going to isolate the variable. So I'm going to divide by 64. So I get 1 over 64 is equal to 1/2 to the n minus 1. Well, do you see that I can write 1 over 64 as 1/2? So watch this. I'm going to write 1/2 to the 6th power, because 1 to the 6th is 1 and 2 to the 6th is 64, right? Can I erase this over here? Do you guys have this written down? Did you guys follow what I did here?
Miss Bruce,
Go ahead.
why do you make it equal to 1?
Okay, because the problem, so the problem is saying the players compete until there's one winner. And what's happening here, the reason why we're setting it equal to 1, the final round is going to have one match. And so what we're doing is we're taking out this f of n is the answer, right? F of n is y. So we're taking out f of n and putting 1 in for the final round. That's what we're doing, so we can solve it. Did you guys follow this part though, right here?
Wait, so how did you get 1/64 to 1/2?
Okay, hold on. So I divide, okay, so does everybody see how I divided both sides by 64? Divide by 64.
Yeah.
And now you're asking me, how did I get, so what I'm trying to do is so I can use this property over here, I'm getting the bases to be the same. So I can write 1/64 as 1/2 to the 6th power because 1 to the 6th is 1 and 2 to the 6th is 64. So what I'm doing is I'm getting the bases to be the same because if I can get the bases to be the same, I can use this property that says I can get rid of the bases and equate the exponents. 6 equals n minus 1. Eddie, did you follow that?
Yeah, okay. Thank you.
Okay. I know it's a crazy rule. And honestly, I've never seen the name of this rule. And in one of the books we had, it never even stated the rule. I had to like bring it up. So I don't even know the name of this rule, but I do know it exists. And we are gonna look at it when we solve exponential equations, which is coming up. But anyhow, so n is equal to 7. And what that means is the winner must play 7 rounds. So we want to know how many rounds did the winner have to play? They had to play 7.
So we don't have to use the recursive rule to solve this one?
No. When we solve problems, we could use the recursive rule, but we're not. We're just going to solve the problems. They always ask us to write both, but to solve the problems, we're always going to use the explicit rule to solve the problems. It's just because it's easier.
Okay. But is there any times where you would have to use the recursive rule?
I never have. I've never used the recursive rule to solve. No.
Okay.
Okay, now I want to show you a couple of problems. Can everybody look at this? Practice AB. All right. I want to focus on these middle problems. So can you guys look at this? Like number 5. Now, number 5 is an easy problem. And the reason why number 5 is easy is because they're giving us the first term and we can figure out the common ratio. Easy. But take a look at problem number 6. They're giving us the first term, but we can't figure out the common ratio. They're not giving us consecutive terms. They're giving us the first term and the third term. So how do we do it? So you can't straight out write the explicit rule and the recursive rule. So let's take a look at this. And what I want you to do, I want you to write these down so you see the process. But when you come to it, I don't want you to just copy it out of your notes. I want you to try to do it to see if you can do it exactly the way I'm doing it. All right, here we go. I am done with the lesson, by the way. I'm just looking at practice AB right now. Okay, this is number 6 in practice AB, and they're saying the first term, that's what that subscript means. The first term, or the first position, is 16, and the third position is 4. So we know the first term, but how do we find the common ratio? Watch how I'm going to do it. I'm going to take my explicit rule for the first term, for having the first term. Watch how I'm going to do this. I'm going to use him to figure this out. So I'm going to look at the position 3, and wherever I see, I'm going to put the a sub 1 in, 16. And wherever I see an n, I'm going to put a 3. And now, isn't the third position 4 the term? Isn't the term in the third position 4? So see how I'm going to be able to solve for r? Isn't that cool? So I put in the third position, and I wrote who's in the third position is the term 4. And so what I have now is 16r squared. Well, I can have a quadratic. I'm going to solve a quadratic. So I'm going to divide both sides by 16, and I get a quadratic, which is 1/4. And now I'm going to take the square root of both sides. Don't forget plus or minus. So I have plus or minus 1/2. Now, which one is it? Positive or negative? Well, it looks like my terms are positive. So I'm just going to say r is equal to 1/2. And now I can write my rule. And I should have read the directions. They're wanting us to write an explicit rule for the geometric sequence. Okay, so let me finish. Let me finish real quick. So our answer is f of n is equal to the first term times 1/2 to the n minus 1, where n is greater than or equal to 1. So that's what they want, is the explicit rule based on the given terms. And also they're saying assume, they're helping you. They're saying assume the common ratio is positive. But still, well, pay attention. Remember I told you that I don't like your work? Make sure when you take the square root of both sides, you put plus or minus. You always do that, regardless of the problem. Because when you get into trigonometry, if you're not used to doing that, you are going to be messed up. So trigonometry is what's going to tell if you're able to put plus or minus or not. That's why I'm trying to train you to put plus or minus every time you take a square root. All right, questions? Eddie, do you have a question? Anyone?
So you use 4 on the left number because that was what was given, right? Because I can't quite see that. Does that say A3? Oh, yeah. Okay.
A sub 1, so the first term is 16, and the third term in the third position is term 4.
Okay. I wasn't sure because at first I thought you used 4 because it was 4 minus 1 is 3, but I couldn't see it.
Yeah, no problem. Okay, so now this is what you're going to do when you're missing a variable. So if you're missing A and they give you R, you can find A. If you're missing R and they give you A, you can find R like we did. Now here's the question. What if you're missing A and R? Take a look at number 9. Actually, let's see which one I want to do. Take a look at number 11. You don't have the first term. And you don't have consecutive terms. You can't find the common ratio. What now? In Algebra 1, they should have taught you how to solve a system of equations in 2 variables. Now, I don't know if they did or not, But the teacher should have taught the stacking method. There's different names for this. This is called linear combinations, or it's called elimination. So if you add these, you can solve for y, and then you go back and find x. Do you guys remember doing this at all? Well, here's the problem. There's different ways to solve a system of equations. So a system of equations is used when there's two unknowns. Now, some teachers only teach this. And that's not good, because when you're a high-level math teacher, this is not going to work with geometric sequences. So this is the most, this method called elimination or elimination or linear combinations. It's the most used method, but it won't work for geometric sequences. So what we have to do is use a method called substitution. Okay, so let me show you. So we're looking at number 11 on the practice AB. And it says the second term is 80 and the fifth term is 10. Well, like I said, we don't know the initial term, a sub 1. We don't know the common ratio. We don't know anything except that it's a geometric sequence. And so watch what I'm going to do here. I'm going to keep this rule in mind. And watch what I'm going to do. I'm going to write f of 2 is equal to AR, which you're missing, to the 2 minus 1. Because wherever there's an n, I'm putting a 2, right? Now, the term in the second position is 80. And that's going to be one of my equations, so I'm going to put a little star by it. My second equation is going to be f of 5, and we're still missing a and r. Now it's going to be 5 minus 1, and so the term in the fifth position is 10, ar to the fourth. Now, because our variables are a product, we can't use elimination and linear combinations like I just showed you a minute ago. What we have to do is this, watch. We're going to put one equation on the left, and we're going to put we're not going to stack them, one equation on the right. And this is called substitution, by the way. And what we're going to do is solve for any variable. It doesn't have to necessarily be y, or you can solve for any variable. Now, what do I mean by that? I'm saying solve for the easiest variable. What do I mean by that? What do you think I mean by that? Solve for the easiest variable. Okay, it means solve for a variable that doesn't have a power. Okay, like solve for this a, that r, or that a. Don't solve for that r over there. Okay, so what we're going to do is you can pick any variable you want, and what I'm going to do is I'm going to solve for that r. So I'm going to divide both sides by a, and I get r is equal to 80 over a. So what I just did is I solve for r in terms of a. Okay, now I'm going to get a different color. Watch what I'm going to do. I'm going to substitute this in for r over here. So I get 10. Let me do it in pink. I get 10 is equal to a times 80 over r to the 4th. Now, does anybody know 80 over Amy? Does anybody know why I did that? Like, why did I solve for a variable in terms of the other? And why did I want the pink?
So that way we only have one variable.
Exactly. So we're solving for A. Now let me just tell you what's going to happen. We're going to solve for A, and then we're going to substitute back and find R. Okay, here we go. So don't try to cross cancel or you'll violate the order of operations. What you have here is 10 is equal to A times a really big number. And this number is 409, 6 with 4 zeros, over a to the 4th. So 80 to the 4th is 409, 6 with 4 zeros, a to the 4th. Is everybody okay so far? So now I can cancel the a's. So when I cancel the a's, I get 10 is equal to 4096123 over a cubed, and now I can set up a proportion. So now what I have is I have 10a cubed is equal to 4096123, and when I divide by 10, I can cancel one of the zeros. So it's 4096123, and now I'm going to take the cube root of both sides. Don't put plus or minus. So I'm taking the cube root of both sides, and I get A is equal to what? Now get your calculator out and tell me, what's the cube root of 4096000?
Hundred and 60.
Okay, I'm 160. So now we have the first term, finally. So now what we're going to do with the different color orange is I'm going to put this back in over here. And so you get 80 over 160 equals R, which is R is equal to 1/2 when you cross cancel. Now, why did we do all this? We did all of this so we could write this rule. So here's my rule. My rule is f of n is equal to the first term, which is 160 times 1/2 to the n minus 1 for n greater than or equal to 1. Okay, I'll take questions now. So you're going to do this when you're missing A and R. You're going to set up this is called a system of equations. Two unknowns. And for geometric sequences, we're going to use a method called substitution, which means you're going to solve for the easiest variable. And you're going to do exactly what I'm doing. Now, if you solve for this variable, you're going to substitute this way. If you solve for that variable, you're going to substitute this way. So it doesn't always look like this. You can either substitute this way or substitute this way. But you're always solving for a variable in terms of another. You're going to get one variable and then turn around and find the other one. Are there any questions? Last call. All right, now, like I said, when you come across these problems in the practice AB, don't just copy them off your paper. I want to see if you can do them with the correct notation. Remember, when you take the square root of both sides, you put plus or minus. when you take an odd index like cube root, fifth root, don't put plus or minus. And here we go. I changed the Math Wizard teams. So you have new Math Wizard teams. And here's what I want you to do. When you go into your new team, you are going to introduce yourself and you are going to name the one thing that you like. Name one thing that you like about working in the Math Wizard teams. If you don't like anything, then just state what you don't like. But you're going to introduce yourself to your team. You're going to name one thing that you like about working with the teams. If there's nothing that you like, then you can say what you don't like. Okay, now we have most of the period. I'm going to be taking attendance in the teams, and we're going to work on the practice AB. I don't know where it went right now. Somewhere I had it. Right here. So we're going to be working on the practice AB for the geometric sequences 12-2. All right, okay. Class is over today at 10:45. You're going to report back to me at 10:40, just in case you have any questions. All right, so let me write that up here. Let's come back at 10:35 to WebEx. Class is over at 10:45. You're going to come back at 10:35 to WebEx. Okay, any questions? All right, I'll see you in your teams. All right. Did you guys make it back?
Yeah.
Okay. There's a couple things I want to go over. And I know it's Friday and I know you're tired. I'm tired too. I get it. I need you guys to really focus though. Okay, because I'm going to clear up some stuff right now. Ready? All right. On the practice AB, can you see that problems number 1 and 4 are the explicit rule? And do you notice that they left off the domain? I don't want you leaving off the domain because you're going to be required to write the domain. So on both of these problems, number 1 and 4, they should have written for n greater than or equal to 1 because you have the first term. Okay, can everybody see that problems 2 and 3 are recursive? And do you notice the 3 things that you have to write when you write the recursive rule? What are the 3 things? They're writing the first term. They're writing the recursive rule. What's that?
Are they writing the ratio?
They're not writing the ratio. Not on the recursive rule. So what they're doing is they're writing the first term. They're writing the recursive rule, and they're writing the domain, which is 1 greater than the explicit rule, right? Now, I think what Diane's trying to bring out is that they are writing R at the end instead of the beginning. So if you look at my notes, see my finger where I have R at the beginning? They're trying to trick you, and they're writing R at the end as times 3.5. So as long as it's being multiplied, it doesn't matter if it's the beginning or the end because multiplication is commutative, which means the order doesn't matter. So for sure, R is 3.5. Can you guys unmute yourself and tell me that you understand what I'm saying?
I understand.
Understand.
Okay. All right. So so I'm gonna go on in a minute. Let's take a look at number 1. Do you see that the explicit rule, you can tell what A sub 1 is right away, right? Because in the rule, A sub 1 is just staring at you. What's A sub 1? What's the first term? Go ahead. What's the first term?
11.
And what's the common ratio?
2.
Okay, now, can everybody see that? Because it's in the form. You guys okay or no?
Yeah.
All right. So what I want to do now is I want to look at number 9. So number 9 is the fourth term. The term in the fourth position is 135. And the term in the fifth position is 405. Well, in order to write the explicit rule, you need the first term, you don't have it. You need the common ratio, you don't have it. But can't you find the common ratio? Look aren't these consecutive? Isn't this position 4 and position 5? So can't you find the common ratio by taking 405 divided by 135, which is what?
3.
Now, watch. Do you realize that you can use either one to find the first term? And I'm going to show you just to prove it. So the rule is f of n is equal to a times r to the n minus 1 for the first term. So if I want to use this one, we would say f of 4 is equal to a times r to the 4 minus 1. Sorry. That's right. You with me so far? Wherever I see an n, I put a 4. And now we know the fourth term is 135. So what you have here is 135 equals 27a, divide by 27. A is equal to what? 5?
Yeah, 5.
And if I use the other one, I could say f of 5 is equal to a times 3 to the 5 minus 1. And we know the term in the fifth position is 405 is equal to a times 3 to the 4th. So 405 is equal to 81a. Divide by 81. A is equal to 5. So I'm just proving my point. You do not have to do both of those. You're just doing one of them. Now, which one do you want to use, Enrique?
The one with the smallest exponent?
Exactly. So when I was in Enrique's group, that's why I called on him. He said, let's just use the easiest one. Well, this isn't the easiest one. Look at the big numbers. So you would want to use the one with the easier numbers, but I'm just proving to you that either one works. And now you're ready to write it. What is the rule? F of n is equal to a, which is what? 5 times
3.
3 to the
N minus 1.
and you're not going to forget the domain, right? So whether the book's missing it, whether the practice A is missing it, I don't care. I want you to write the domain. You have the first term, so it's going to be greater than or equal to 1, right? Right? So like I said, if you're missing A and have R, you can find A. If you're missing R and have A, you can find R. Or if you have to solve a system of equations with two unknowns, you can use what I showed you called substitution. All right, any questions?
Ms. Birch, can you do number 10, please?
Number 10, we won't have time for. because number 10 is a system, but I'll set it up for you. Because number 10, see, number 10, you don't have a sub 1, so you don't have the first term, and you don't have consecutive, so you don't have, you're missing A and R. That's the worst case. So you're going to have to solve a system. So they're giving us the third term, which is 400, and they're giving us the fifth term, which is 256. So we're going to use this. But you're going to have to use substitution to do this. Watch. So you're going to take f of 3 is equal, we don't know A, we don't need no R, but this is going to be 3 minus 1. So we know the term in the third position is 400. So there's one equation we're going to use. And we have the fifth term, which is, we don't know, to the 5 minus 1. We do know the fifth term is 256, but we're still missing A and R. And so what you're going to do is you're going to write those side by side and solve for the easiest variable in terms of the other. Find it, go back and find the other, using substitution like I modeled in class. So this is the problem. This is the long problem that I worked in class using substitution. Do you understand how I set it up though?
Miss Birch,
Yeah.
I'm just a bit confused because we tried to solve 400 equals AR squared, and we didn't know whether to divide the A first or square root it after we divide the A.
Okay, the first thing you want to do is you want to solve for A. Don't solve for R squared. So the first thing you want to do is, if you're going to solve for that A, divide both sides by R squared. Understand?
Can you do an example of that? I'm a bit confused.
You don't want to take a square root on the first one. By the way, it's 10:45. So those of you who have to leave, you can watch the video. Class is over, but if you want to hang out, I'm not going to work it, but I'll set it up for you. So the first one is 400 equals AR squared. And the second one is 256 is equal to AR to the fourth. And I told you to solve for the easiest variable. So you're going to solve for A. So you're going to divide both sides by R squared. So you get A is equal to 400 divided by R squared. So that's what you're substituting into the second one. So you're taking this and you're putting it in for A there. So what you get is 256 equals A, which is 400 over R squared, because you're putting that in, times R to the fourth. So what happens is that cancels and you get 400 R squared. Now you solve for R. So like I said, for the first one, you solve for the easiest variable. So you would be solving for A. You're going to substitute that in for A over there, and you cancel those two.
Wait, Miss Bird. So if we could, if we wanted to, though, I'm not saying I would because it's harder. But if we were to divide by A, wouldn't it would be 400 over A equals R squared, and then you would do the square root. So
Nope, because if you divide by A, when you take the square root, you have to put plus or minus.
Oh, I mean,
Remember?
Yeah.
So you have to put plus or minus. So you have to consider plus or minus. Don't forget that.
Yeah, I forgot about that. 'Cause I was thinking because it was R squared. I mean, R to the fourth, where you would just where it would just be easier.
Yeah.
But it's way easier to divide by R squared.
Yeah, because you're creating, you're being a little risky in doing what you said. We don't want to be risky because we might lose something.
Okay.
Because remember when you take the square root of both sides, you have to put plus or minus.
I was looking at the problem. My first thought was, oh, it won't be that bad because it's R to the fourth power, and then it's just a square root. But I forgot about the plus and minus.
So Eddie, let me just tell you, I would either solve for A here or solve for A there. Do not solve for R in the first step.
Okay. Thank you.
Yeah. All right. I hope you guys have a great day.
Have
Now
a
you know what
good
you're
one.
going to do, right? You're going to solve for R. Then you're going to come back here and find A.
Okay.
All right. Have a great day, guys.
Bye, Ms.
Thank you, Ms.
Birch.
Birch. Thank you. I
Have a good
understand that.
weekend, Ms. Birch.
You guys have a good weekend. Bye, guys. Have a good one.